Hi, and welcome to a bite-sized tutorial. In this one I will mostly look at the very basics of GDScript and maybe explain some key differences between GDScript and C#. I will probably do this in multiple parts, but let's start with looking at what GDScript is and maybe look at a few differences compared to C#. GDScript is the main language of Godot, and for all of you non-programmers there's visual scripting. These are nicely integrated into the editor, and while I haven't tried out visual scripting, GDScript is a nice and smooth experience. You do have the option to use C# and C++ as well, but for beginners I would suggest to stick with GDScript, since there are more tutorials and help to find online. And you don't need a separate IDE if you use GDScript. If you're coming from Unity, you might already be familiar with C#. So, as you might know, C# is a statically typed language, which means that the variable types are explicitly declared and checked at compile time. What's good about this is that any type errors are caught before the game runs. GDScript, however, is a dynamically typed language, meaning that the variable types don't need to be defined and are determined at runtime. So, you could just add a new variable called distance here and let's set the value to 20. And in the ready method, print the value. By looking at this, we can tell that it's an integer, and as you can see, we don't end each line with a semicolon, and this because GDScript, as a few other languages, rely on line breaks to separate statements. Instead, it relies heavily on indentation, and I'd say it really helps make the code readable. And while you can add semicolons, I would recommend against it to follow the standard conventions of GDScript. Now, hit play and you can see that the value gets printed in the console. And because it's a dynamically typed language, it means that you can change the type of the variable to a string like this. And if I hit play, you can see the new message in the console, 10 meters. And while this might not seem like a big deal at first, you might come to a point where you want to actually handle the distance variable as an integer. Maybe you want to divide the value by 2 for some reason. This would now throw an error when I hit play, because you can't divide the string by 2. So, I would say that you should always define the type of a variable, which you do by adding a colon after the variable name, followed by its type. And now you can immediately see this throwing an error here, and take care of it before it causes bigger problems. So, my first tip would be, even though it's optional, to always define the type of your variables. Future you will be very thankful. Now, to expose this variable in the inspector, you can use the export annotation, which you add right before you declare your variable. And if I save the script, I can now see and update the value right here in the Inspector tab. And similar to the header attribute in Unity, you can organize your variables into different categories to make it easier to navigate them in the Inspector. You do this with the export category annotation. Let's pretend I'm creating a player script. I could have a category for general settings specific for the player for variables such as health and speed. And another category for the weapon and have, say, damage and ammo. If I save this script now, I can see my new variables here in the inspector under their respective categories. Let's finally have a look at 3 important methods to keep track of. First, you have the ready method. And feel free to correct me if I'm wrong, but from what I've gathered, this is the equivalent of the start method in Unity. As you can see here in the comment, the ready method is called when the node enters the scene tree for the first time. Also worth a mention is that single-line comments are written with a hash symbol. And multi-line comments that can span over multiple lines are enclosed within triple double quotes. And back to the ready method. So, it's called as soon as the node and its children are added to the scene and are ready to use. This is where you would do the initial setup of your node and initialize the values. Let's now have a look at this process method. As you can see in the comment, it's called on every frame and is the equivalent of the update method in Unity. It is suitable for non-physics related operations such as animations, input handling and other real-time updates. Delta here represents the time elapsed since the previous frame and is typically used to make movements and animations frame rate independent, such as delta time in Unity. Another method for handling updates is the physics process method, which is the equivalent of the physics update method in Unity. The main difference between these two methods lie in when they are called and their intended purposes. The physics process method is tied to the physics frame, gets called at a fixed interval, and is suitable for physics-related calculations such as character movement and collisions. Knowing when to use which of these methods could be crucial for both the performance as well as the behavior of your game, regardless of the game engine you use. I feel like we've covered the very basics of GDScript now, so I will stop this here to actually keep this bite-sized. But hopefully you have found this video somewhat helpful, and I will soon publish a second part digging a bit deeper into GDScript. If you have any questions, suggestions or feedback, please feel free to let me know down in the comment section. Thanks for watching, and I'll see you in the next one.